Good morning, all of you students. So, welcome to again lecture series on T.Y.B.Sc physics of the subject which is the solid state physics. And we have to continue here the first chapter or first module which is the crystalline state. In summary of the last lecture, we have to see here what is meant by actually solid state physics and what is the main types of the solid which are crystalline solid or amorphous solid. So, crystalline solid which is given as the regular order arrangement of the substance or the constituent particle which is known as the crystalline, or amorphous solid which is considered as does not have the regular order arrangement of the constituent particle. This is known as the amorphous solid, and that amorphous solid which is considered as the isotropic. Why consider the amorphous solid which is the isotropic in nature? Because these are the property such as electrical conductivity, thermal conductivity, mechanical strength or refractive index of these are same in all directions. That's why the amorphous solid which is considered as the isotropic in nature. And why say in the anisotropic nature of the crystalline solid? Because this such property that electrical conductivity, thermal conductivity, mechanical strength, refractive index, this all property are different in the different direction. So that's why we have to say that this is the anisotropic nature. So we have to see here the main basic difference between the types of the solid, that is the crystalline solid or amorphous solid. So consider as first of all, so the main which is the solid and two main part of this solid. So first which is the crystalline solid. Crystalline solid, and next main part of this solid which is given as the amorphous solid. So that solid are classified into two groups. So crystalline solid, or next group which is the amorphous solid, and that which is given as, so what is meant by the crystalline solid? That is arrangement in a definite order. Crystalline solid which is given by arrange in a definite order or regular arrangement or regular and as well as periodic arrangement of constituent particle. This is known as the crystalline solid. And what is meant by the amorphous solid? That amorphous solid which is does not have definite order or regular or periodic arrangement of the constituent particle this is known as the amorphous solid. After that, the crystalline solid, which is given as they have same bond strength. This is first point. Second point, which is given by that all crystalline material, so that is they have in the same atom or molecule, so they have same bond strength. They have same bond strength as well as they have sharp melting point. They have sharp melting point. Next point, which is given as, which is considered as in the amorphous solid, that amorphous solid which is does not have same bond strength, does not have same bond strength, and also does not have sharp melting point. Sharp melting point. So this is the main property. And next, which is third point in the nature of the crystalline solid, which is the anisotropic nature. And in this amorphous, which is given as the isotropic in nature, because have the such property of thermal conductivity or electrical conductivity or mechanical strength of the material. So that depends upon, these are the main points of the solid, that is crystalline solid or the amorphous solid. So next point we have to consider here, what is mean by the lattice or what is mean by the basis. So we have to know that, so that crystalline structure consider has the definite arrangement or regular arrangement or periodic arrangement of the material of the matter, which is considered as the crystalline. Same phenomena that in lattice, that have arrangement of infinite numbers of the imaginary points in space, arrangement of infinite number in a imaginary space or imaginary point in a space, and that each point having the its identical surrounding, that is known as the lattice. So see, or this lattice or basis very basic, which has got the clear idea about the solid or nature of the crystalline or amorphous, that depends upon the lattice structure and the basis structure, and that due to this lattice or basis we have to form the crystalline state. So that we have two interesting here. See that the point which is given as the lattice. What is mean by lattice? So then arrangement of infinite and arrangement of infinite numbers of imaginary point. Numbers of imaginary points in a space with each point having with each point having identical surrounding. Identical surrounding is known as lattice point, okay, or is known as the crystalline lattice. So what is meant by lattice? So that is lattice which is considered an the arrangement of infinite numbers of imaginary points in a space with each point having the identical surrounding. This known as the crystalline lattice. And if we see the crystalline lattice, that perfect crystal, we have to say that perfect crystal. How? So that perfect crystal, there is a property of the regular order arrangement of atoms and the periodicity in the arrangement in the different directions, and that is the understand of the periodic pattern of the atomic arrangement in a crystal, and that is the convenient to imagine the points in a space about which atoms or molecule can be located or labeled us to concept of the space lattice. Okay, so that is the idea of the lattice. So simply what is meant by the lattice? So that is lattice which is given as the arrangement of infinite numbers of the imaginary point in the space. So for example, what is types of the arrangement of infinite numbers of of the points in a space? So that is considered as, so for example, this imaginary point, this point, this point, this point, the arrangement of this point in a space, which is the regular arrangement or periodic arrangement. So simply say that this dot structure we have to see that have also follow the orderly arrangement, which has also follow the periodic arrangement, okay, and the space or distance between that point which is also same. So that is known as that infinite number which is having the regular arrangement of the constituent particle, and that particle which is known as the lattice. So this is considered in a two-dimensional space. If we want to consider in the three-dimensional space, that lattice may be defined as the finite array points in three dimensions in which every point has the identical environment as any point in the array. So that is known as the lattice in the three-dimensional space array. So what is mean by lattice? So that is the infinite numbers of the imaginary points which is arranged in the space which is regular arrangement, or that is considered in the three-dimensional. So that is the finite array of the points in three dimension, which is the points has identical environment, each point having the identical environment. So that identical environment which is like this, that is the regular arrangement or the periodicity. So this is the idea about the lattice. Next point which is given as what is meant by basis. So that is basis which is meant by the uniform arrangement of the points in the space, and that crystal structure which is formed associating with the every lattice point, that is known as the, or that unit assembly which is known as the basis, or actually that is the crystal structure which is not lattice, but a lattice is the imaginary concept, and that is say that the lattice array of the atom. Few seconds or few minutes we have to see here what is mean by lattice. That is, lattice is the indefinite arrangement of the imaginary points in the space. That is mean by the lattice, and that lattice, it is totally imaginary concept. We have to describe the solid, and that crystal lattice that is shown, the figure we have to draw here, and that is the definite or regular or periodic arrangement of the points, and that arrangement of points have been shown in any point that is completely equivalent to the points in the structure. So we have to draw here the diagram of the crystal lattice. So that crystal lattice, consider that is the regular arrangement of the points. So consider as, so next point we have to see here what is meant by the basis, or what is, or how it is separation between the crystal lattice or the basis point. So that basis point which is given as the point separation or regular arrangement of the points is like this way. So this regular arrangement of a point, or this regular arrangement of this imaginary point in the space, which is known as the, that figure A, which is given as the crystal lattice. Next point which is given as how the structure of the basis, that the structural unit of the crystal, it is known as basis, and which may consist of an atom or ion or a molecule. So what is mean by basis? So see here the point which is considered as basis. So what is mean by this basis? The structural unit of a crystal, the structural unit of a crystal, and that is called the basis. Crystal is called basis, and that basis which may consist of an atom, which may consist of an atom, molecule or ions. So this is known as the basis, and we have to the figure, so that is B, which is given as the basis, and this is considered as two circle, which is considered as the solid circle or empty circle. So this is known as the basis. Next phenomena which is considered as the crystal structure, or how to develop the crystal structure, that is lattice plus basis, which is known as the crystal. So we have to draw here the structure of the crystal or crystal structure, which is given the basic phenomena, that is this crystal lattice, or that crystal lattice plus this basis is equal to crystal structure and how it is look like at. So for example, original, so these are the crystal lattice point, okay, or this is the periodic or regular arrangement of an constituent particle, so that is known as, that is considered as the lattice point. So this type of regular arrangement of the lattice or imaginary point in the space. So we have to know that what is mean by crystal structure, that is crystal lattice plus basis, which is the crystal structure, and this basis point which is seen here as closely packed structure like this. Or we have to know that, so that phenomena of the this basis, the one circle which is solid circle and which is considered as the empty space, and the compact configuration of this crystal lattice as well as the basis which is given as the crystal structure, draw like this. So this is very important or very interesting phenomena to understand the properties of the material based on the solid state physics. Consider like this, or simply study of this, how it is the nature of the crystal structure or peak or compact structure of the crystallography. Consider as this structure is which type, that is simple cubic or body BCC, FCC, and other many types of this. So which is considered or depends upon the various phenomena of the properties such as electrical conductivity, thermal conductivity, or quantum mechanical phenomena. So that depends upon. So this is the basic structure of the crystal structure based on the lattice point plus basis point to have formed the crystal structure, and this is known as the crystal structure. So this is see figure in the figure 1.1. okay. So this is the phenomena or consider. So what is mean by the crystal structure? That crystal structure which is given as lattice plus basis is equal to crystal structure. Lattice plus basis is equal to crystal structure, and that crystal structure considered as 2 point, so that is lattice, and next point which is given as the basis. So what is mean by basis? That basis which is the structural unit of the lattice, which has considered the atom, molecule and the ion, and that array point in an identical way in the lattice, that is array point in an identical way, or this is in the basis which is considered as a group of atoms or molecules, or molecule or ions which is consider as identical in composition arrangement. Identical in composition arrangement. So this is the idea of the what is meant by the lattice and what is meant by the basis, and next lecture we have to see what is meant by the translation vectors.